Hi, good morning. This is the e-learning day video for Honors Math 1. Today, this video is just going to go over the answers to the homework from earlier in the week. So you had two review sheets for 8-7 through 8-9. So here's the answers for the first handout. So I know some people had some questions on finding the component form and the magnitude for AB. So again, remember when we label vectors, we label them with two letters. And again, I know it's not that clear, but right, again, for these symbols, right, where the arrowhead is on, that is where the direction in which the vector is going. So with this label as vector AB, so what can help sometimes is to kind of draw a little sketch. And so here these are ordered pairs, so I graphed point A and I graphed point B. Right, and because the arrowhead is on B, we know, in terms of the symbol, we know that that's the direction that the arrow is going, or the vector is going. Okay, so it's going from A is the tail, B is the head of the vector. Okay, so again, to define the horizontal and vertical components, then you start at the tail end, and you make your way towards the head. So I need to go to the left, right? That's for my horizontal component. So I have to go to the left 3. So that means -3 for the horizontal. And I had to go down 1 for the verticals. Alright, so here are the horizontal and vertical components for vector AB. Now another way you can do this, right, if you don't graph, especially again when the numbers here are higher, is you can take the tail ordered pair and subtract, the head ordered pair and subtract the tail. And you should get the same numbers for the horizontal and vertical components. So again, over here, I'll go and demonstrate that. So the head is at B, the tail is at A. So I'm going to subtract these two. Alright, so I've got, for B, it's -1, 3. For the tail, it's at 2, 4. Oop, that should be a comma. Alright, so when I subtract, so I'm going to do the horizontal, the x numbers first. So -1 minus 2 is -3. And 3 minus 4 is -1. Okay, so this is how you can also, if you're not really into the graphing, find it hard to kind of graph, you can use this, right? Taking the ordered pair for the head and subtract the ordered pair for the tail. And that will get you your horizontal and vertical components for that vector. Remember for magnitude, right, and it's just taking your horizontal and vertical components and setting it up in what we paralleled it to the Pythagorean theorem. Right? So we take horizontal component squared, vertical component squared, add them together, and then take the square root. Right, so here, I didn't graph this one. I used, right, this B minus A, or head minus tail way of finding the horizontal and vertical components. So when you do that, you should get 11, 5. So again, 8 minus a -3, -1 minus a -6 to get this vertical component. Once you get the horizontal and vertical components, then you plug it in this formula to find the magnitude. Okay. Next, we are finding vector U. Okay, so here, when you're given vector V, horizontal and vertical components, vector W, horizontal and vertical components. All right, so here we're going to find vector U, V plus W. So here I'm going to use the parallelogram method. And so coming out here from the origin, I have vector, what is this? So this is vector W. Coming out of the origin, same starting point, I have vector V coming out this way. So this is V down here. This is W over here. So again, parallelogram method means we have to make a parallelogram. So at the end of vector V, I'm going to do another vector W. And coming out of the end of vector W, I'm going to do another vector V. Completing the parallelogram. And again, remember the solution vector is you start at the common starting point and you go to the direct opposite vertex. So it's hard to see right here, but this vector inside parallelogram, that is U, vector U. Okay. Here for number 4, vector U is described as 3 times vector V. So again, vector V has horizontal component 2, vertical component -1. So here's vector V, and because I want 3 times that, I'm just going to have to do that 2 more times. So here is the illustration of 3 times vector V, or again, vector U. Alright, so the rest of this worksheet, again, you could think it's pretty self-explanatory. You can feel free to pause the video if you want to take a longer look at some of these solutions. And again, if you have any questions regarding this answer key, then shoot me an email and I'll get back to you as soon as I can. Alright, so that is review sheet number 1. Moving on to review sheet number 2 for 8.7 through 8.9. So again, here we're given vector P and vector Q in terms of horizontal and vertical components. We want to find vector R. So for number 1, vector R is defined by vector P plus 3 times vector Q. And we want to use the end-to-end method. So again, end-to-end. So we're going to start at starting point. So here, coming out of the origin, I have vector P. And then at the end of vector P, I'm going to do 3 times vector Q. So you see again the 3 arrowheads showing that I am doing 3 times vector Q. Okay, so the solution vector using the end-to-end method comes from, you start at the initial starting point, and then you go in the direction of the head of the last vector. So here's vector R. For number 2, again, we're going to use the parallelogram method for this one. So it's 2 times vector P. So again, here I'm going to start at the origin as my common starting point. So coming out of here is 2 times vector P. From this common starting point, I'm going to do, minus or negative vector Q, and that's this vector Q going in the opposite direction. So here I have vector Q coming out of the same starting point. So again, parallelogram method means we got to create this parallelogram. So at the end of vector negative Q, I have 2P. At the end of 2P, I have another vector negative Q. And then the solution vector comes from this common starting point. Go to the direct opposite vertex of the parallelogram, and that is our solution. Horizontal and vertical components method. Again, you're just taking the horizontal and vertical components of the two vectors. Okay, so here is 4 times vector P. Here is 2 times vector Q. And so again, we just add the horizontal and vertical components to find vector R. Okay, so again, I'm just going to show the answers for 4 through 7. They should be pretty self-explanatory. Again, we're just using this vector to write examples of these different matrix properties. For number 8, right, we're given this 2 by 2 and we want to use systems of equations method for finding the inverse. Number 9, we want to use the determinant way. Alright, and finally for number 10, we're going to matrix would not have a multiplicative inverse if the value of the determinant is 0. Alright, that's it for today. Again, don't forget to submit your solutions for yesterday's homework. You guys have a great day.